Another way to quickly find the greatest common factor of two or more numbers involves prime factorization. Every number can be made by multiplying a set of prime numbers. This is known as prime factorization and is covered in another video. We find the prime factors by dividing out prime numbers one at a time. So for a quick little review of finding prime factorization, let's take a look at the prime factorization of the number 200. We begin by dividing out the prime number 2, and we can break our 200 down into 2 times 100. 2 is prime, so that stays here on my next level, and 100 gets divided by 2 to find that it's 2 times 50. We continue down to the next level, keeping our prime numbers of 2 and 2, and then we factor 50 by dividing again by 2 and seeing that 50 equals 2 times 25. We keep our next level here with our primes of 2, 2, and 2, and we factor out 25. 25 is not divisible by 2, it is not divisible by 3, and we move to our next prime number of 5 and find that 25 is divisible by 5. It equals 5 times 5. So the prime factorization of 200 equals 2 times 2 times 2 times 5 times 5. Let's look at an example of finding the greatest common factor using prime factorization. We are asked to find the greatest common factor of 120 and 160 using prime factorization. So what I have here is my two numbers, 120 and 160. And the greatest common factor of two numbers can be found by finding the prime factorization and then looking at the prime numbers that are shared by both numbers. So in my 120, I've broken it down to, I divided out a 2 and got 2 times 60. So 2 is a prime and I leave it, and my 60 I've divided down to 2 times 30, or broken into 2 times 30. The 2's all remain as they are because they are prime numbers, and we then divide out a 2 from 30 and have 2 times 15. And finally, our last final step here, our last final level of this pyramid is the prime factorization of 120, which is 2 times 2 times 2 times 3 times 5. Now then similarly, we've done the same thing here with the number 160. We've continued to divide out prime numbers until we got down to the lowest level here, the last level where we have all prime numbers. So 160 divided by 2 equals 80, so we have 2 times 80 on this level. Our next level we have 2 times, and then 80 is 2 times 40, so 2 times 2 times 40. Then 40 gets divided by 2 to equal 2 times 20. On this level then we have all our prime numbers and 20. The next level, all prime 2's with a 10, and our final level of prime factorization of the number 160 is 2 times 2 times 2 times 2 times 2 times 5. So now that we have the prime factorizations of both of these, we are going to look for the prime numbers that they both have in common. The greatest common factor, GCF, the greatest common factor can be determined by finding the prime numbers, the prime factors that are shared by both numbers. So in this case, with the prime factorization of 120 and 160, they both contain 3 2's. So I could even circle them one at a time. This one has 1 2, this one has 1 2. This one has a second 2, and this one also has a second 2. This one has a third 2, and this one also has a third 2. Now this one has a fourth and a fifth 2, but this one over here does not. So I need to stop circling the 2's. Then I move on to my next prime number in the factorization, and in this one I have a 3. But this one does not contain a 3, so I'm not going to circle the 3 at all. They have to have them in common. And then here I have 1, 5 in this prime factorization, and I can see that I also have 1, 5 in the other one. So I can circle my 5s. And so then what I do is I simply take one of these, the representative will be this one. I'm not going to do 2 times 2 times 2 times 2 times 2 times 2 times 5 times 5. I'm just going to take it once. So I look at one of them and I have all the common prime factors circled. So I'm just going to take this one and I'm going to write it out in my multiplication. 2 times 2 times 2 times 5 equals my greatest common factor. So 2 times 2 times 2 is 8 times 5 is 40. And so 40 is the greatest common factor of 120 and 160. So this is the method for using the prime factorization of two numbers to find their greatest common factor. We can also check our answer using the other method that we were first looking at for greatest common factor. And that is taking all the pairs of whole numbers that multiply together to equal our number. And then from those pairs listing the factors of our number. And then similarly here with our number 160. And so we can see that listed out like this, we can circle the common factors of 1, 2, 4, 5, 8, 10, 20, 40, and that is it. No, there are no larger numbers than 40 that exist on both lists. And so from listing out the pairs of whole numbers that multiply together to equal our number, and listing the factors, and then circling all those that are common and finding the greatest of those, we see again that our greatest common factor of 120 and 160 is 40. Let's look at a real-life example of finding the greatest common factor of three numbers using prime factorization. So Sally is making fruit salads. She has 78 blueberries, 104 strawberries, and 130 raspberries. Each salad must contain the same amount of each berry. So our question is, what is the largest number of salads that she can make? We want to find the greatest common factor of 78, 104, and 130. So we are going to look at the prime factorization of each of these numbers. And then we are going to see which prime factors our three numbers have in common. So for 78, if we divide 78 by 2, we get 39. So we know that 78 equals 2 times 39. 39 is not divisible by 2, but it is divisible by 3. So 39 divided by 3 equals 13. And our prime factorization then of 78 is 2 times 3 times 13. For 104, we divide by 2 and get 52. 52 we can divide by 2 to get 26. And 26 we can divide by 2 to get 13. And we have our prime factorization then of 104 is 2 times 2 times 2 times 13. And lastly, for our prime factorization of 130, 130 is divisible by 2, which gives us 2 times 65. 65 is not divisible by 2 or by 3, our first two smallest prime numbers. So we go to our next prime number, which is 5, and we see that 65 is divisible by 5, and it equals 5 times 13. So the prime factorization of 130 is 2 times 5 times 13. Now our next job is to find which prime factors these three numbers have in common. So I can see that all three of them have a 2. So I'm going to go ahead and circle the 2 in each of these. Now this one here, 104, has 2 more 2's in its prime factorization, but these two don't, so we can't circle any more 2's. We have a 3 here, but no 3's in these two, so we can't circle the 3. Similarly, we have a 5 in this prime factorization, but no 5's here, so we can't circle the 5. But we do have a 13 in all three of our prime factorizations, so I can circle the 13. And then what I do is I take one of these that I have circled the common prime factors for. I'll take this one here. And I take the prime factors and multiply them together. So I have 2 times 13 equals 26. And that tells me then that 26 is the greatest common factor of these three numbers. So the answer to my question then, what is the largest number of salads that she can make, is going to simply be my greatest common factor. So she can make 26 salads. To answer our question about making the fruit salads with blueberries, strawberries, and raspberries, 26 is the greatest common factor of 78, 104, and 130.